for new. In this video I am going to talk about recursive functions in Python. So first of all we have to discuss about the recursion. Recursion is a way of writing code in programming languages where the program called itself. And in other words, if I have to explain it, a function that calls itself directly to solve a smaller version of its task until a final call, which does not require a self call, is a recursive function. So let's just try to learn about it, and first let's see how we are familiar with the recursion in our day-to-day world and in real life. So here are some examples. As you can see, this is a fine example of golden ratio. So in golden ratio, so there is a huge rectangle and then this squares are being divided between 1.61 ratio between the two sides. So if I take a ratio of this particular part and this particular part, it would be of ratio of 1.618 and so on. Then similarly in this particular part, the ratio between these two blocks would be 1.618 and so on. It keeps on going, and that's called a recursive function in real world. Similarly, we have some more examples like this particular diagram. So each individual element has the exact same structure as we see in this particular view. If I select a particular shell here, it would just have the same structure as we are seeing right now in this particular diagram. Similarly, this is the sunflower. It has the same golden ratio or the recursive pattern in nature. Similarly, this particular succulent plants, I say, or some kind of cactus, where they have the similar structure of recursiveness in nature. And this famous Mandelbrot diagram or set has a similar recursive nature. If we zoom out on a particular element, it would again have the same structure, so on, and same again the shell. So these are certain examples in nature where we find the recursion, and now let's see how we achieve in the Python. So as the definition says, a function which calls itself, right? And let's just try it randomly here. I write a function and I am calling it again in the return, and if I do, I probably know the error would about to come, and then it says recursion error. So maximum recursion depth exceeded. So in programming languages, every programming language saves itself, does not want to go on an infinite loop of doing this recursive functions. So there is a limit set. So in Python, the kind of value of that particular limitation is 10 to the power 4, and this kind of issues are called stack overflow issues, where it consumed all the stack of the programming language where it could have done the recursion method or recursion function. Similarly in Python, if you want to increase the recursion limit, just import sys and sys.set recursion limit, and I'm not going to execute this particular set, but this is for anybody who wants to manipulate with the backend of the programming language. Now the famous example of Factorial, the only one from where we can start. It's the most familiar, like hello world in any programming language. So learning recursion starts with learning the Factorial methods. And why it is a good example? Because it shows us why exactly we need to learn the recursion first of all, and how well we should know how to write that particular recursion function in the code finally. So let's take an example of the Factorial. So I have n to the n factorial, and certainly the formula would be n into n minus 1 factorial. How does it sounds like now? So now if I have to calculate the n minus 1, so again if I look at this particular formula, it would be again n minus 1 into n minus 2 factorial. So every factorial, whatever n value you are asking for, it is asking back, give me the value of n minus 1 factorial. And then the n minus 1 factorial value would ask, okay, give me my n minus 1 factorial, and it will keep on going so on until it reaches 1, where 1 factorial is 1, and it stops there. We don't want to do n minus 1 there because 0 factorial is kind of undefined, or 1. Similarly, if I look into an example of factorial, 5 factorial is 5 into 3 into 3, 5 into 4, I'll just write it here, 4 into 3, and similarly that's how it would be. Now if I have to speak about this particular function, it kind of looks like a dog chase. So where a dog is trying to chase the tail. Whenever we are doing n minus 1 factorial, it says give me n minus 2 factorial and so on. So they are keep on chasing their own tail at every other recursion. So let's see how to write a kind of a recursion for calculating the factorial. So I have a simple factorial function and I'm saying if x reaches 0, don't do anything, just return 1, and else x to the factorial of x minus 1, what we were talking about so far. And if I just execute it, and I get my values as fast as I could. Now the interesting point here is what we have exactly done here is we have written where we would face this particular kind of failure or recursion error at one point. When we increase the values to the extreme like 10 to the power 4, it would throw us the error because it would exceed the limitation of the programming language, for now the Python. So this particular example has a very specific issue of tail recursion. The reason in this particular function we are following the particular thing which we discussed during this particular example of 5 factorial, that the function is awaiting a response from the next recursive function, that is the factorial calculation of x minus 1, meaning it still has to keep hold of whatever has been performed here, and hence it would keep on stacking the stacks and it will consume the memory at the end, and hence reaching the particular error of recursion error even when our code is doing perfectly fine. So to solve this particular kind of problems, we have to write a code in such a manner that it would execute a tail recursive function rather than just a recursive function. So why tail recursive functions are better, I will just write it here. The reason is the particular function does not wait for the next, but rather just pass on the information to the next stack, and then whenever that execution of that stack would be completed, it would just return the value at the nth stack rather than keep on holding the stacks of the previous steps. Or the another way to write is, or another way to understand the tail recursive function is, you just define a factorial. I mean, let's say for the same particular task, the new way of writing a tail recursive function would be define a function, pass whatever value you have, and also passing another variable which would hold the value of that particular end result value or to the next step value. So what will happen? So same, I'm just returning the final value, and else I'm calculating and calling the same recursive function factorial trail with the same parameters, but this time using this particular, so x into n minus 1 kind of. So n minus 1 value would directly get calculated into x, and hence giving me the final x factorial value. If you watch closely, the function is finally returning, and then we can just pass on this information to the next stack, and then we can forget about the previous stack, and hence this function is kind of a tail recursive function. The output would be exactly similar, it won't give you the error of tail recursive or recursion error over the longer period of time for higher value of the values. So this is one of the example. The another example which most of the time we get to see are factorial or fractal trees. So this is a very fine example. This example you can use to learn the recursive functions clearly, and frankly speaking, recursive functions are like the more you practice, the better it would be, and even later on you would be surprised that there are some better ways of writing the recursive functions on a very specific given problem statements. So let's see how to create this particular kind of a diagram or a fractal trees in Python. So for this particular purpose, I'm using the turtle library or a package, and I will just give a brief. I won't be explaining the turtle. So what exactly we are trying to do is, that would be really helpful on understanding the recursive functions. So this is our starting point where you can see the particular arrow key, And what we want, okay, we want to move ahead, and then I will just draw it. As you can see, we move ahead, we took another angle on the left side, we move ahead, another angle, another angle, another angle, till the point the condition met. And right now the condition is the length of the branch should not be greater than 10. So once it reaches here, what we are doing is we are back tracing our path. So we reached here, we took the right angle, or towards the right side, we create the branch and check whether the length is enough or not. So certainly the the length condition would met, and it will again backtrack, and then again it will go right. It will create the branches, it will create the other two branches, then again it will go backtrack, again it will go backtrack, it will come here, again it will take right angle or the right side, again it will again start tracking by the condition of the length. And just imagine, just by doing the recursive function or learning the recursive function, this much amount of code helps us on creating a beautiful diagram such as fractal trees. So there are so many other such examples. I'm sharing this particular notebook as well so that you can experiment on it. I would strongly suggest to give your time on creating this diagram so that you can learn the concept of recursive functions in Python. I hope you got the concept. If you like my videos, please consider subscribing to my channel and like this video as well, and have a great day. Thank you.